Hey everyone, welcome to today's Explainer. We're diving into something I like to call the invisible infrastructure, software engineering. Think about it. Software is kind of a massive paradox, right? On one hand, it's just pure, indestructible logic. But on the other, it eats up billions of dollars in maintenance just to keep the lights on. Today, we're unpacking exactly why that is, how this whole digital foundation is structured, and the wild, ongoing challenge of keeping it all alive. So here's our roadmap for today. Section 1 is all about the nature of software. In Section 2, we'll break down the broad software categories. And finally, in Section 3, we're tackling the legacy software challenge. Let's just jump right in. This concept perfectly nails our first big takeaway. Software is absolutely engineered. It is not manufactured. We are not talking about some factory assembly lines stamping out identical physical widgets here. Software is born straight from intricate problem solving and human creativity. Sure, the industry is definitely shifting toward component-based construction, snapping together pre-built blocks of code, kind of like Legos. But the reality? Most software out there is still custom-built from the ground up to solve very specific challenges. All right, that brings us right into Section 1, where we really need to examine the nature of software itself. Here is the mind-blowing difference between classical manufacturing and software engineering. Physical stuff, it completely obeys the laws of physics. It deals with friction, environmental wear and tear, and eventually it just breaks. But software? Software literally doesn't wear out. It's executable code existing in a purely digital state. You could run a program 10 billion times, and the code itself won't experience a single ounce of physical fatigue. This indestructible nature is a total game changer. It shifts the entire burden of failure away from physical wear and onto things like changing environments and shifting dependencies. So, where exactly is all this indestructible code? Let's move to Section 2, broad software categories, and see how this actually manifests out in the wild. Because software is custom built for, basically an endless variety of problems, its applications are incredibly diverse. When we step back and look at the whole ecosystem, we can group software into 7 broad, changing categories that essentially run our entire world. Let's break these down into a couple of manageable chunks. First up, we've got system software. Think of this as the bedrock. These are programs written purely to service other programs, like the operating system quietly running in the background of the device you're using right now. Next is real-time software. This stuff monitors, analyzes, and controls real-world events the exact millisecond they happen. Then there's application software. This is actually the single biggest chunk of the pie, completely dominated by business information processing. We're talking massive databases, global logistical trackers, you name it. And rounding out this first half, we have engineering and scientific software. These are your heavy-duty number crunchers designed to solve incredibly complex mathematical models. Moving right along, category number 5 is embedded software. This lives inside the intelligent products we see everywhere today, from your smart fridge at home to massive precision factory robotics. Sixth is product line software. This is your everyday personal computer stuff, word processors, spreadsheets, graphics editors. Number 7, web applications. These aren't just static pages anymore. They pull executable instructions and rich multimedia straight through your browser. And finally, artificial intelligence software. This is where we use non-numerical algorithms to tackle incredibly complex problems, like image and voice pattern recognition, where standard, straightforward math just doesn't cut it. Now, keeping all 7 of those categories in mind, I've got to ask you something. We just established that software is pure, indestructible logic that physically can't wear out, right? So why on earth are we spending billions of dollars fixing and updating old programs? It's a massive paradox. And that perfect contradiction leads us directly into our final stretch, Section 3, the Legacy Software Challenge. Let's define what we're actually up against here. Legacy software basically refers to older programs that have been in continuous focus of attention and concern since the 1960s. Just let that sink in. The 1960s. We have core systems originally engineered decades ago that are still keeping IT teams awake at night today. Researchers like Daiani Fard and his team have actually dug into exactly why these older systems demand so much babysitting, despite never actually breaking down. According to Daiani Fard's research, there are 4 massive forces acting on legacy software. The code itself doesn't change, but man, the world around it sure does. First, the software has to be adapted to entirely new computing environments or emerging technology. Second, it has to be enhanced to meet new business demands, because when a company scales, its software has to scale right there with it. Third, it has to be extended so we can interoperate with modern systems. Basically, it has to learn how to talk to the new kids on the block. And fourth, it often needs to be completely re-architected just to survive in a modern network environment. I really want to zero in on that first point because it absolutely hits the nail on the head regarding the reality of software engineering. Quote, the software must be adapted to meet the needs of new computing environments or technology. A piece of code from 20 years ago might be mathematically flawless. It hasn't worn out one bit. But the hardware it runs on, the operating systems, the security threats, they have all completely transformed. Software is essentially a living, breathing document that has to constantly evolve to survive in an ever-shifting ecosystem. Which wraps up our explainer for today. We've seen that while software is this incredibly engineered, indestructible creation powering 7 major pillars of our world, it is completely at the mercy of its changing environment. So, I want to leave you with a thought to chew on as you go about your day. Take a look at the digital tools you use for work, for life, for connection. Is the invisible infrastructure you rely on actively adapting to the future? Or are you actually running on legacy code, just waiting for the environment to change? Thanks so much for hanging out with me to unpack this fascinating topic, and definitely keep questioning those invisible systems all around you.